Hello friends, the purpose of this video is to get us some answers to this fundamental counting principle homework where we had to look at bit codes and then YouTube videos. So I'm going to do this actually in Microsoft Word because I had a couple questions this week which I thought were great about how to type fractions in a Word document. So I thought that was really cool. So I'm going to show it to you. I'm going to show you how to do that in Word. So we're doing 128-bit encryption. How many possible codes could there be? Okay, so in Microsoft Word, since there's two options for each of the bits, it's either a 1 or a 0, one way to write this would be 2 to the 128th power, which, and I mentioned this in our videos and also in our Zoom meetings, that's you use the caret to represent that, 2 to the 128th power. Another way you can write it, if you want it to look like an exponent, you can type 2 and then 128, and then you can superscript the 128 to make it look like an exponent. It's not functioning as an exponent in Word, but at least it looks like an exponent if you want it to be that way. And then if we want to see what that number actually is, which is going to be helpful in a second, we can type in Google 2 to the 128th and press enter, and it can handle it. And it's just a massive number. I don't even know what number that is, but it's 3.4 times 10 to the 38th power. So I'm just going to copy that if you want that number. And we'll drop that into our Word document. Okay, so that would be the answer to number 1 if you wanted to know the numerical value. Okay, so number 2 says we are no longer, let me back, where are we at here? Here we go. We are no longer using the super slow Sean computer. We're going to use a supercomputer that can test 1 billion codes per second. How long in years will it take this supercomputer to test all of the pins from number 1? Okay, and I said it's a hell of a long time, and that's an understatement, and you'll see why in a second. So let me show you a way to drop an equation into Word. I've showed a couple of you ways to do this using what are called field codes, but those are clunky and a little bit old school like me. But at the same time, I'm going to show you a new way here. If you go to your insert menu and you have, I don't know what version of Word this showed up during, but if you wander over here, there's a section for equation. And if you click equation, you'll notice that you've got this really cool equation tools bar up top. And the only one we need to use right now is a fraction. That's how you can drop a fraction. And you hit fraction, and then you can select whatever format you want. I think this is probably the best one to look at. And then you might notice right here, what it does is it drops a fraction bar, and it drops a numerator and a denominator section. So you can put in 2 to the 128th codes. Whoops, I just spelled codes wrong. So you can put 2 to the 128th codes. Or if you want, you can put that number in there too. I'm just going to put 2 to the 128th. We'll deal with that in a second. And since that's technically over 1, I'm going to write that fraction as 1. So there's how you can put a fraction in. Now what's cool about this is we can now put another fraction right next to that one. Okay, because we need to be able to convert this number of codes into time using the conversion that the super fast computer in 1 second can do 1 billion codes. 1 billion codes. I'll put a space there. There we go. So now what's kind of cool about this is you have a codes up here and a codes down here. Now, if you want, and it says if you want, you can go inside this fraction, and then you can actually use the strike through command to show those codes dividing off. Now you're down to seconds. So now if you were to do this math right here, you'd know how many seconds it took to crack all those codes. But I asked for years, so we have to convert seconds down even more. So I'm going to use my next fraction, insert equation, fraction, and I'm going to go seconds to minutes. So I know in 1 minute there are 60 seconds. All right, and now if you want, you can come over here and strike out seconds, And now you're down to minutes if you worked the math right now. I'm not working the math right now because I want to get the entire expression and then deal with it once I've got the unit I want, which is years. Okay, so we're at minutes. We better get to hours. Let's see, equation, fraction. All right, I know that 1 hour is 60 minutes. All right. I can cross off the minutes, dividing those off. Doing really well. We're getting hours. I think we're getting close to years. We can go hours to days, days to years. I'm going to insert an equation, a fraction, and we're going to go 1 day is 24 hours. All right, and I'm just going to go ahead and, whoops, cancel those hours. Good. And then finally, times, and I think there's a more precise number than 365, but I am just going to use 1 year is 365 days. Totally fine. And we can now divide off days. So if you take a look at that beautiful expression, that monster, the only unit left is years. So all we have to do is do the multiplications now. So if you look at the numbers, it's 2 to the 128th times 1 times 1 times 1 times 1 times 1. Well, that's 2 to the 128th. That's that number right there. We then have to divide that number by all of these numbers multiplied together. Now, I'm going to use Google again because it's my favorite calculator. And I'm going to show you how to do this whole thing at once. Whenever I have to do one of these dimensional analysis things with a bunch of fractions, I group the numerator in parentheses like we did in Math 98. And then I'm going to divide that by the denominator, all the multiplications. So that's a billion, 1,000, million, billion, times the 60 seconds for a minute, times the 60 minutes for an hour, times the 24 hours for a day, times the 365 days for a year. And this is going to do the math that that string of fractions I just had in the homework implies. And when you do that, check it out. Oh my goodness, yes. 1 times 10 to the 22nd years. So you got to remember this number. Please remember this number. If it was 10 to the 3rd years, it would be 1,000 years. If it was 10 to the 6th, it would be 1,000,000. 10 to the 9th would be 1,000,000,000. 10 to the 12th would be 1,000,000,000,000. You can see now why 128-bit encryption would be fairly safe even for a computer that can crack 1 billion codes a second, because that's how many years it would actually take to crack every single one of those, or to try every single one of those pins, even though by all means it would probably happen somewhere in the middle, but still that's the maximum number of times. So there you go. More importantly, the math is important, of course, but I wanted to also show you, of course, how to do these fractions in Word, because a few of you had been asking. Okay, back to the homework. The next questions are about YouTube file names. Okay. What I was really interested in is these characters at the end of YouTube file names. If you ever go to YouTube, which I'll do in a second here, you'll notice the shares that come always seem to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters after them. So that's the answer to number 3. There are 11 characters to the right of that. 11 characters. Spelled that word wrong, but we can fix it right here. 11 characters, okay? I'm also giving you a pretty good example of how to submit your homework if you ever wanted to use a Word document. This is perfectly acceptable, except I didn't answer number 2. I'd have to actually tell you what the answer to that was, which we did in the Google video, or in the Google window. Okay. Let's get back into it. I checked a number of videos. Yep. And they seem to be, these symbols are either upper or lowercase letters, and they're seemingly random. I found out actually they are random. We'll come back to that in a second. If there are 26 uppercase possibilities and 26 lowercase possibilities, that means every single one of these spaces has 52 options to choose from. So this one right here is a capital H. It could have just as easily been a capital A, a lowercase Z, a capital Q. There are 52 possibilities for this, and 52 possibilities for this, and 52, and 52. As a matter of fact, for each of the 11 spaces, there are 52 possibilities. So using our fundamental counting principle, it's 52 times 52 times 52. And you know what? I rather than write it like that, let's write it as 52 to the 11th power, which you can also write if you want to use the superscript idea to write it, 52 to the 11th power. And if you want to know how big that number is, again, Google is your buddy. 52 to the 11th power. So that is a slightly smaller number than over here, thankfully. A little bit easier to deal with. It's still one of those things that's hard to name. I think that's probably in the quadrillions, but I'm not entirely sure. Maybe quintillions. Doesn't matter. It's huge. It's a huge number. And as a matter of fact, it's wrong because as I Googled around more, as I YouTubed around more, I noticed they also are using digits 0 through 9. Not just upper and lowercase letters. So they still can use upper and lowercase letters, but some videos actually use numbers, digits in the spots too. So that adds 10 more possibilities. So in number 5, it's actually going to be not, I'm going to copy and paste if that's okay, my friends. It won't be 52 to the 11th. It's going to be 62 to the 11th. And if you want to know how big that number is, and I can change 52 to 62. It's going to be exponentially bigger. There you go. About 10 times bigger. There you go. Okay, now that's the technical end of the homework. That was the last question on the homework. I've lost it now. Hang on, let me find it. Here it is. This number 6 is extra. I question, is it enough? Is that last number you just got, 10 to the 19th power, is that enough addresses? Can that address all of the YouTube videos that are currently out there? And the reason I made this an extra credit question is nobody actually knows how many YouTube videos are out there. A lot of you tried this question. A bunch of you got it right, which was awesome. The challenge is YouTube doesn't tell you how many videos are out there. When you ask how many YouTube videos are there, it comes back with things like this. Total number of people who use YouTube, 1.3 billion people. Well, that doesn't tell you how many videos are there. It tells you how many people use it. You know, a sizable chunk, a sixth of the world's population uses YouTube. This also doesn't tell you. 300 hours of video are uploaded to YouTube every minute. Almost 5 billion videos are watched on YouTube every single day. None of those numbers actually tell you how many videos are on YouTube. How long would it take to watch all the videos on YouTube? That doesn't help, because it says by the time you finished one video, there will be 1,000 more added to the website. Now, from some of this information, you can make up your own, I call these back of the envelope calculations. So for example, every minute, 300 hours of video are uploaded to YouTube. If you somehow knew how long a YouTube video was, that might be able to give you an idea of how many videos are uploaded. So I'll show you that for a second. So we know that, I'm just going to do a little number 6 here, a little something. We know, based on what we just read by that little thing that just kind of went by in the night there, that 300 video hours are uploaded each 1 minute. Okay, every 1 minute, 300 video hours are uploaded. Now, if you could somehow do a conversion and get the video hours out, you could maybe be able to convert video hours to videos. So when I suggested, some of you actually asked me about this last week, I said, well, make up a number. How long do you think a YouTube video is on average? And you all had very, very different answers depending on what kind of YouTube videos you watched. So some folks said one YouTube video is equal to, I don't know, let's make up a number, 3 minutes. 3 minutes. Well, 3 minutes is 1/20th of an hour. So one YouTube video is the same thing as 0.05 video hours. And you see what I just did right there, besides spell video wrong? If you do that, you can then divide off the unit of video hours uploaded. If I can actually do this, hang on. I'm trying to select just video hours. Here we go. You can divide off video hours. And then if you do this math, 300 divided by 0.05, you now know how many YouTube videos get uploaded every minute. So we'll just do that. 300 divided by 0.05. Oops, I don't know if the decimal point. So that means about 6,000 YouTube videos are being uploaded every minute. From that assumption, per minute. From that assumption, you can extrapolate that out like you did up here to figure out how many YouTube videos have been uploaded since the beginning of YouTube. Just FYI, YouTube's only been around 15 years. So I'm going to take a quick little trip down memory lane here. How many minutes in a year? I'm going to speed up the process here because I'm watching. This is now a 16-minute video and I want to knock it down even more. So there's 525,600 minutes in a year. If I take 15 years, 7 million minutes. So if you take 7 million minutes and multiply that by the 6,000, multiply by the 6,000 YouTube videos per minute, you end up with this number here, which ends up being 47, what is that, trillion, 304 billion YouTube videos. So that is, if you think about that in terms of scientific notation, that is 10 to the 10th. 10 to the 10th. Well, 10 to the 10th is nowhere even close to as big as the numbers you're getting here. These numbers were 10 to the 18th and 19th. So you've got way more potential addresses available than you actually do YouTube videos that are out there. Even with these are ridiculously overestimated numbers. I mean, yeah, maybe this is true. Maybe currently there are 6,000 videos being uploaded per minute, but there weren't in 2005 when YouTube was first formed. So my thought is that, yes, there are plenty of addresses out there. I've often wondered why the number 11 was chosen. I like to think it's because, or why the 11 spaces are chosen, 11 characters. And I like to think it's because the folks that coded this are Spinal Tap fans. But the real reason eludes me. However, I will say, and I'm going to leave this is something for you to think about, while I was talking through this with some of your classmates, we stumbled upon, I think I Googled, why does YouTube use 11 characters for sharing, blah, blah, blah. And we found this video right here. Will YouTube ever run out of video IDs? So I called these things file extensions, but they call them, well, this guy calls them video IDs. This is a great little 5-minute video if you want to watch it. He walks through quite a bit of the same math that you did in this homework, but he actually goes further and explains things that I didn't know either. So now that we're coming up on 20 minutes on this video, I am going to say I'm done. I'm sorry. I don't like to make videos this long usually, but I wanted to take my time and kind of two birds, one stone. I wanted to show you how to do fractions in Word and also get your questions answered. Hope it helped. We'll see you in class.